All right, ladies and gentlemen, our topic today for this next unit is all about functions. So today we're talking about function basics. The last unit we did was about solving equations, basic equations, complex equations. Now we're actually going to use those equations to dive a little bit deeper into algebra. And that leads us to the topic of functions. Make sure you put the page number and your date on your notebook. The page number you should be on is page 38, and your date is November 4th. Please be careful and make sure that your page numbers match the page numbers that I give you. It's good for us all to be on the same page so that I can just simply say, hey, go to page 42 in your notebook, and you all know exactly what I'm talking about. And the date, too, make sure that you just put the date that the video is assigned. It's going to help keep things more organized, and it's going to get you much better notebook check grades come the end of the quarter. So our objective for the day is I know what a function is, and I can recognize functions in both graphs and in tables. Okay? So let's talk about what a function is, and this should go on the same page. A good way to think about functions is to think about machines. Let's say you have a vending machine that has a whole bunch of different kinds of soda, and it has a place for you to put money in and a place for you to select what soda you want, right? So you put money into the machine does something with that money, and then out of the machine comes a lovely cold frosty beverage for you to drink. A function kind of works the same way. We put something into our function, like with this arrow here. The function machine does something to it, and then a different thing comes out of the function. And in math speak, one input, something you put in, causes one output. So if the left-hand side of my function machine here, and draw this in your notebook, please. The left-hand side is the input, okay, what goes into the function. It's also what we call the x value, okay? So if you have an equation like y equals 3x plus 2, the x value is the input, okay? Another word we use to describe the x values of a function is domain. Honestly, I don't know where math people came up with that word, but they love it. They use it all the time. So you need to know all four of these words and know that they all go together. Okay, so this input goes into our function machine, and something that you're going to see a lot in functions in this unit is something that looks like this, f parentheses x. In math, we usually say f of x, and x is the domain, the x value, the input, what goes into the function. So you might see a function written like this, f of x equals 2x minus 4. And this 2x minus 4 is the rule that tells you what to do to the x value that you're putting into the function machine. So then what comes out of the function machine, what the output is the y value. The y value of my function. It is the range of the function, and it's what happens after you put this rule, whatever your function machine rule is, into the machine. Then something comes out. So looking at this function that we have, f of x equals 2x minus 4, let's say I put the number 8 into my machine. Okay, that's my input, it's my x value, it's my domain. I put 8 into the machine. If I take this f of x equals 2x minus 4, and now I put in f of 8, the function, that's where the f comes from, the function of 8 equals 2 times, instead of x, it's 8 minus 4. 2 times 8 is 16. We then subtract 4 and get 12. So when my input was 8, what goes in the machine, my output, what comes out of the machine, would be 12. That is the basic idea of what a function is. It's a rule and it tells you what to do to your input to get your output. Okay, so now that we have that concept kind of explored a little bit, let's look at some examples of things that are and are not functions. The most important rule for deciding if something is a function is this: every input can only have one output. For example, when I put 8 into this function machine, the only number I can possibly get is 12. Who would want a vending machine where sometimes you put money in and get a soda, and sometimes you get money in and you get no soda? That wouldn't be a very effective machine, would it? You want something that is consistent. One input gets one output. You know what's going to happen to it. So let's look at these different diagrams that I have here. This first one has the domain listed, the x value, the input, listed as -3, -2, -1, 0, and 1. It then has my range listed, and we have these arrows that show what happens when we put a -3, a -2, a -1, 0, or 1 into my function. So -3 is always going to go to 3, -2 is always going to go to -6, -1 to 0, 0 to 15, and 1 to -1. They always go to the same output. Therefore, this is a function. Let's take a look. I want to skip this one for now, and I want to go down to the one here on the bottom. I have -3 always going to -6. I have -2 going to -1, -1 going to 0, 0 going to 3, but now I have a problem. This diagram says that if you put a 1 into your function machine, sometimes you'll get a 0. Follow that arrow. Sometimes you'll get a 0. And sometimes you'll get a 15. That breaks the #1 rules of functions. Every input can only have one output. So this example here, this diagram, is not a function. Finally, let's look at this one. This is a little bit of a unique situation. Just by looking at it, you see that all of my inputs go to the exact same output, -6. So you might be thinking to yourself, oh, that can't work because it has to be this, every input only has one output. But think about it. If you put -3 into this machine, you're going to get -6 every time. -3 only goes to -6. Same with all of the other numbers in my input. So that means that this one is a function, because every single input only has one output. Okay? Make sure you did put that page number and the date on that page, guys, also. Now let's look at graphs. Okay? When we have a graph of something, we can use the vertical line test to decide if it is a function. The vertical line test is exactly what it sounds like. It is a vertical line, just like that. If I take my vertical line and put it over the graph of my relationship, what I have on my graph, it is only allowed to touch the graph at one spot at a time. So here, where does my vertical line touch the graph? Well, it touches it right there. And it only hits the graph here being this little blue line, it only hits that graph once. Okay, well that's good. And I move it over here, and look, it only hits the graph one time right there. Let's move it a little more and see what happens. Uh-oh, we have a problem, because that vertical line hits this graph in 2 places. That means it is not a function. If anywhere in the graph of your relationship, this blue line is the graph of some relationship, if anywhere it hits the graph twice, it is not a function. So let's take this same vertical line and bring it over here to this other graph. So if I make it cross my graph on this XY axis, my graph here being this parabola, that's that curved shape, when I cross my vertical line over that graph, there is no place where it hits the graph of that line more than once. Now, people get really confused here with the xy axis and the actual graph of a function. The xy axis is just kind of like its background, okay? It's kind of like when you have a map and you have the grid lines on a map that tell you kind of where you are. It's just part of the background, and what's really important is the other line drawn on it. That is what we're concerned about. So yeah, this vertical line crosses the x-axis and the graph of our function, but that doesn't matter. We only need to see if it crosses the graph of the function more than once. And no matter where we put this vertical line, it only touches the graph one time. That means that this graph is a function. Okay, so let's move on to the reflection question. Oh, I didn't give you a reflection question. Whoops, let me make one real quick. Given this graph, I need you to tell me, is it a function or is it not a function? And make sure you include why you believe your answer is correct. Okay, I'll see you guys next time. Bye.